Suppose if I consider this is our y direction upward as positive y, this way is our positive x. And it is told that rain is falling vertically down. So the velocity of the rain will be minus 2 j cap, no? Because it is told that rain is falling vertically down with 2. And the boy starts from rest and moves with some acceleration which is constant on a straight road. So suppose this is the person or the man moving on the straight road and starting from rest. So his velocity after time t, I can use v equals u plus at. Since u0 acceleration is 2, so that velocity of speed of the man will be 2t in suppose the rightward direction. If I ask you what will be the velocity of the man in terms of the components, you tell me that will be 2t I cap, no? So now next job is to find the velocity of the rain with respect to the man. So velocity of the rain with respect to the man will be velocity of the rain minus the velocity of the man, and that is going to be minus 2 j cap minus 2t I cap. So velocity of the rain with respect to the man has got x component minus 2t and y component minus 2. So if I ask you draw this vector graphically, then what really you will do? Just a moment. Post that thing again in the group. Correct. No offline class. No offline, but 2 3 students only offline. Those who can come offline, for them offline. Just a moment, I'll post it again. I'm doing this question. Exercise 3 question. You have the module related question. Exercise 3 question number 7.
So we aren't starting the new lesson.
No, I'll start new lesson. I was waiting for others to join. So in the meantime, I thought I'll solve a question. You can keep here. No, it will belong. Keep here. You live like near only, no?
Not exactly 4 kilometers.
So for
So yesterday
10 minutes, 20 minutes, no?
15.
By cycle. 15, okay. So what we
Yesterday I
have
left
is,
my cycle here.
okay.
Rained.
So during a rainy day, rain is falling vertically with velocity 2 meters per second. And a boy who starts moving from rest, but with constant acceleration on a straight road. So the rate at which the angle, so suppose at any moment, the axis of the umbrella is kept at an angle theta from the vertical. So what is the rate at which that angle theta must be changed so as to always keep the axis of the umbrella along the velocity of the rain with respect to the man so that he can save himself from the rain. So if I consider upward as positive y, if I consider upward as positive y and this side as positive x, so velocity of the rain will be minus 2 j cap because the rain falling down with 2. Right. And the velocity of the man, since he's starting from rest but moving with constant acceleration, so I can write his velocity will be u plus at u0. A is 2, so he will be moving with 2t at any time t.
So
So
why is U0?
they're telling us starting from rest. Boy starts from rest
Okay.
and then he moves with acceleration 2. So at any time t, he will be having this much velocity. Suppose he travels this side. So velocity of the man with respect to the ground will be 2t I cap. So velocity of the rain with respect to the man will be Vr minus Vm. And now we got a vector whose x component is something negative, y component also negative. So I will try to draw that vector graphically. It is having x component also negative, y component also negative. So this vector should be making some angle which is acute with negative x and negative y. So how much is the y component it has got? It is minus 2. How much the x component it has got, which is minus 2t. So the angle this is going to be making with the vertical is this angle. Similar question we did in last class, just it was something easier. And this is how he must be keeping the umbrella to save himself from the rain. This angle will be phi only. So this length is 2t and this length in that triangle is 2. So tan phi, that angle they are calling it as theta. Why I should tell phi? That angle they are calling it as theta. So tan theta is going to be equal to 2t by 2. So that is t, no? So tan theta is equal to t. Now the problem that anyone will have now, the problem that people will you will face now is how to find d theta by dt. One thing is theta will be equal to tan inverse t. You should be knowing that formula. So differentiation of tan inverse t with respect to t, if I ask you, there's a formula. Differentiation of tan inverse x with we don't have to know that. Just I'm telling this is also there is 1 plus x square. Same way here, differentiation of tan theta, not tan theta, differentiation of theta with respect to t will be differentiation of tan inverse t with respect to t, and that will be 1 by 1 plus t square. But you don't know this formula, you don't have to know. So what we have to find, d theta by dt. Suppose if dt by d theta I can find, that too will do the job or not? Reciprocal of that. So that is what I will do. So t equals tan theta.
Why are we finding the reciprocal?
Because that is easier thing to find. Let's see why. Either you should know this formula or you must do something like this, the one I'm doing right now. So find dt by d theta means differentiation of tan theta with respect to theta I have to do, no? And that formula we know, which is secant square theta, correct? So dt by d theta is secant square theta. So d theta by dt will be 1 by secant square theta, no? And secant square theta is 1 plus tan square theta. And tan theta is t. So what it became? 1 by 1 plus t square. Okay. But this is not the way you should solve. I told that implicit method of differentiation. So here I have equation tan theta equals t. You differentiate every term depending upon what kind of term that particular term is. Like tan theta is a function of theta. So we'll be differentiating it with respect to theta, which will give us secant square theta. Then we multiply it with d theta. Method is like that. If I differentiate something with respect to x, we will be multiplying it with dx. Here I'm differentiating it with respect to theta, we multiply it with d theta. T, a function of t, differentiate it with respect to t, we get 1. We multiply by dt. So what we get, d theta by dt is equal to, dividing both the sides with dt, we get 1 by secant square theta. But the problem is, I have to write answer in terms of t, so I must write that thing in terms of tan theta, because tan theta you know in terms of t. So we get 1 by 1 plus t square. Now you can compare. And that d theta by dt they are asking us is equal to a by 1 plus bt square. Our one came 1 by 1 plus t square. So a is equal to 1, b is equal to 1. So a plus b will be equal to. So it was more of a differentiation question than physics question, no? Because getting that tan theta, everyone can do that, no?
So how did you replace one tan theta?
Tan theta is equal to t, no?
Oh.
So I did that. Same thing I did here, no? I got secant square theta, which I can write at 1 plus tan square theta, where tan theta is t. So we got this. I'm gonna make a note at join one. No problem. I'll start our laws of motion.
So before that, how did we get this tan theta equals to?
So this is the velocity of the rain with respect to the man. I can draw like this. Correct?
Mhm.
Because that vector has got x component minus 2
Minus 2.
negative, y component minus 2. So it must be making some angle with minus y, which should be acute, some angle with minus x, which should be acute. So the component it has got along y is minus 2, component it has got along x is minus 2t. So what is the angle it is making with the vertical? This angle, this is the vertical.
Mhm.
Or I can shift this, maybe I'll take new page there, I will draw it a bigger figure. Just a second. This is the velocity of the rain with respect to the man, is no? So I can shift this arrow parallel to itself. Is it not correct thing to do? So if I shift that arrow and maybe I draw it here, still same only. So whatever angle this arrow has got here, same angle it has got here, no? If that is something confusing. Now, if I decompose this vector, it has got x component of length 2t and y component is of length 2. In that triangle, tan theta will be perpendicular by base. So tan theta will be equal to 2t by 2, no? So we got tan theta as t. So tan theta equals t, that is easy part. After that, it is some pure math thing. But if you don't know, it's not something to be worried about. Now you know. What do I know? I hope all of you got this thing. It's getting recorded as well. I'll share it afterwards, maybe after going home today. So now we are going to start laws of motion, and we are going to start with something which is called as free body diagram. First, I will tell you what free body diagram means, but you will be able to draw only when I have done the discussion of every force is the one that we're supposed to know in the chapter. So how we draw a free body diagram is disconnect the object from the surrounding. From everything that it is having contact. So for whichever object, if I ask you to draw the free body diagram, you disconnect the object from the remaining universe. Replace the points of disconnection replace the point of disconnections with corresponding forces, means whatever forces that were acting at those points of disconnection. Just you write down the points. Once I discuss it, I'm taking a particular example, then only you will understand what really this point means. And then indicate the direction of motion and acceleration. Okay. Now I'll start with something that we know, like force of gravity. That too, we have to know that force of gravity near the surface of the earth. So that force is equal to mg. But where is the point of application of the force? Just I will tell you as a fact right now. Later on, we'll be discussing it in more detail in next another chapter. So point of application where this net force of gravity will act is actually something which is center of gravity. That point is called. But if I consider a point near the surface of the earth where the acceleration due to gravity is constant, in such case, something which is called as center of gravity that you don't have to know right now is same as center of the mass. And that is also something I'm supposed to know right now. The thing that you have to know is where it acts. If mass distribution is uniform, in that case, center of mass, whatever that point is that you don't have to know right now, is same as the geometric center. So where we'll be applying that force at the geometric center, and which way it will be acting vertically downwards, no? Which way? Towards the earth center. Well, there's a chapter dedicated for this force of gravity called gravitation. And in the center of gravity thing, we discuss it in some other chapter where we talk about torque. And center of the mass, we discuss about that in the chapter called center of the mass or chapter of linear momentum. Okay, so that is something which we know about. Next is the normal contact force. So I'm going to save this thing, this PDF also. If you want to write, you can write, or maybe you can take a screenshot. After the class, you can take down the notes. Okay, no, but you must from this chapter. Next is normal contact force.
Can you go and
I'll go back. I'll go back. So the force of gravity near the surface of the Earth, how much it acts on some point object or some object will be his mass into g and acts vertically down towards the Earth center. Where that force we apply it at the center of gravity. And when g is constant, which is the case, which is going to be in this chapter everywhere g constant, the acceleration due to gravity, then center of the gravity is same exact thing as center of the mass. And center of the mass is same exact thing as geometric center. Like for example, what really is the geometric center of a triangle will be? For triangle, it is going to be the centroid of the triangle. For a sub-disk will be center of the disk. So whatever the geometric center is, that is the point where we will be applying this net pull of gravity, which will be equal to mass of the object or that system into g. I hope this point is clear. That is something people know from before as well. Force of gravity is mg, which way it acts vertically down. Okay. Next, I will talk about normal contact force. Someone was trying to join. If I talk about normal contact force, first of all, it is a force that comes into picture only when two objects are in contact. No? But if I ask you, what is the real reason for this force to come into picture in the first place? There is something, someone's trying to join, something which I keep the name as origin of that force. Hmm. Someone trying to join, those who are admin, they can add them again. Origin of this force is something which we call it as electromagnetic. Why? I'll tell you. See, something that we are going to see in 12th class, that electric and magnetic forces are not different. It's something which is called as electric force in frame A. In from different frame B, same force I will be calling it as magnetic force. So whenever we talk about electric force, we don't talk about him alone. We talk about him along with magnetic force. So that's why we call it as electromagnetic. But why electromagnetic? Suppose if I try to touch two of my fingers, but really nothing ever touches, because when I bring two of my fingers like very close, what happens? The electron cloud of one finger will be repelling the electron cloud of other finger, and that force of repulsion that we feel, that is something we sense it, that is something we consider it as sensation of touch, but nothing ever touches. So why really that force coming into picture is because of that electron repulsion. That's why that force is electric and we call it as electromagnetic. How this force acts, what kind of force really nature wise is, it is something which is attractive or repulsive in nature. It is something coming due to the electron repulsion, so it is repulsive in nature. No? So before I go further, I will talk about something which is called as a rigid body. So if I have two rigid body, or suppose if I have a rigid body, what really the one precise way to define an object to be a rigid body is, if I take any two arbitrary points in a rigid body, suppose A and B, whatever the separation that will be between them should not change with time. Correct? No? Or you can say which will not be getting any change in shape, size, dimensions, whatever. So for that, maybe more nice way to define that thing is separation between SEP to the power n means separation, B slash W means between any two points remains constant. And even day-to-day objects, if I don't apply like huge amount of force on them, they can behave like a rigid body, no? Correct? No? So suppose if I have two arbitrary shaped, maybe two curved rigid bodies in contact, then what kind of contact they will have? I can say they are going to have a point contact since they are not deforming each other. Correct? So wherever they are having that point contact, at the contact point, I will drop a tangent. At the point of contact, I will drop a tangent. And at the point of contact, I will drop a normal to that tangent. Since it is tangent to both the surfaces, so we will be calling it as common tangent. And that normal that we have drawn, we'll be calling it as common normal. How this normal contact force acts? It acts along the common normal. Highlight that point. It acts along common normal in a manner to push the objects away from each other, the one which are in contact. push the object away from each other, which objects? The one which are in contact. So if I ask you, draw the free body diagram indicating how the normal contact force, the one which is acting on A, applied by B will be acting on it, and how the normal contact force acting on B applied by A will be acting on it. Because real forces always comes in pairs. For every action, there will be a reaction. Okay, I can take a new page so that I can draw the diagram indicating how the normal contact force will act on it. Maybe I'll try to make a space here only. Suppose if I draw the free body diagram of A and B, trying to show how the force that will be acted by B on A will act and how the force that is applied on B. Just a moment. So always draw the common normal. So, so this is our common normal. Cn means common normal. This is A, this is B. So the normal contact force will act along common normal. So if I ask you how it will be acting on A along common normal, two choice I have. Either it can act on A along common normal in leftward direction. Suppose the common normal is the x direction. Suppose if I say this side is our positive x.
So A and B are directions.
No. So A and B are these spheres which are in contact, which are rigid objects.
So the spheres are in contact.
So I am drawing the diagram. For them, I'm drawing them a little bit separated from each other so as to indicate things clearly.
So common tangent.
The common tangent is this one.
Different.
This is the common normal, no? So this force acts along the common normal in a manner to push objects away from each other. So how the force that is acting on A applied by B will act upon him, it will act along common normal. So either it can act in this plus x direction or it can act in minus x direction. Only two choice it has to act. Either left side or right side, no? But which way it must act on A? In a manner to push A away from B. So which way it should act?
Towards
Left, no? So normal contact force on A applied by B, I will call it as NA/B, means normal contact force on A, who applies it? B. Same will be acting on B, its reaction. So how, if I see independently, the moment I know the force applied on A by B is in left direction, automatically I will know the force applied on B by A will be in rightward direction. That is obvious. But still, if I want to know how the force of normal contact force will act on B, the one which is applied by A, so we don't have like so many choices. Either it will be acting along plus x or minus x because it has to act along common number. But it will be acting in a manner to push object B away from A. So to push object B away from A, it must be acting in the rightward direction. I hope this point is clear. So whenever we have to draw the normal contact force, we must indicate common tangent, common normal, so that it becomes easier to find which is the common normal. We'll take one more example. Suppose if I have a yeah, tell me.
So there's this force acting on B, right?
Yeah, correct.
So that's exerted by A.
Yeah.
But B exerted the force.
Same, yeah, correct. In equal third law, no? Yeah, B is exerting some force, which is an AB.
So no, we don't have to write it like B.
I just so it like who is applying it, I'm writing it like that. Maybe you don't have to write like that. Directly I can write both are same only, no? And they must be equal and opposite. And we understand who applies it. Correct.
So generally, like if a force is given like N A/B and N
Yeah.
B/A, they're different.
A slash B is force on A by B,
Yeah.
and B slash A means force on B by A. They are action reaction pair. They are equal and opposite. So this one is the force on A by B.
Oh, it's inverted.
Yeah, yeah,
Because it's
inverted.
opposite.
Yeah, because they are action reaction pair. No, now suppose if I take a simple case, a block is resting on a smooth horizontal surface, and we have to indicate the forces acted upon him. So tell me, what kind of surface one of them is the one which is, or both of them are flat surface? So wherever they are having contact, if I drop a tangent, who is the common tangent? The flat surface itself. So that's why I always try to draw the common tangent. Sometimes drawing the common tangent will be of some use, you will see. Then whatever the perpendicular to that common tangent will be, that is our common normal. So the normal contact force, the one that will be acting on.
Common normal travels through.
Common normal will be perpendicular. Yeah, it will be.
Like always.
Not always. It depends upon what kind of object it is. First of all, what the size of this block is? No size. So it's a point object. So no, not like so many places I have to draw it. I have a spherical object dropping a perpendicular to that. It must pass through the center because circle have that property. Dropping a perpendicular will be something which is going to be along the radial direction. So if I ask you to draw the free body diagram of this block, let's suppose its mass is m. So the force that will be acted upon him from the ground, the normal contact force like that. Same normal contact force will be applied on the ground by that block. And apart from that, it will be having mg also acting down, no? Correct. So what really have done, I have disconnected this block from the remaining universe, which is nothing but he's having contact with just one thing, which is this surface. So I have disconnected it from this surface. Whatever force that was acting at the point of connection that it was having with the surface, I'm just writing that. No, I'm disconnecting the object, writing, replacing the points of disconnection with corresponding forces and indicating corresponding forces. And I'll write one more point as well. And other forces, whatever might be acting. No, other forces, by that I mean the force that doesn't require contact, which are field forces, no? Because if I ask you, who is really applying this mg? Earth, no? Correct. Even though it was
Gravity.
gravity, even if it was not in contact with the ground, doesn't matter. Pull of the gravity will be same only. Now, next is something different. If I ask you, how much is the acceleration this thing is having? Zero. So acceleration zero, so net force on it must be zero. So whatever n is, that is equal to mg, that is different thing. But how we are drawing that normal contact force on this block along the common normal in a manner to push this block away from the other thing from which it is in contact with, which is the ground.
So with acceleration is zero.
Because it is resting on the surface, so I see that it is not moving at all.
Like you said, we took it away from the surface.
No, how that force act is a different thing.
Oh.
How that force will be acting on this block, it will be acting along the common normal in a manner to push this block away from the ground. So how I should be applying that force, which is the common normal vertical direction. So that normal contact force on A might act along upward direction or may act along downward. But which way it will act? It is a kind of repulsive force which pushes the objects away from each other. Electron repulsion, no?
So it won't be minus G.
Mg also acting, that is different force. Now I'm talking about normal contact force. So on normal contact force, we will draw a bigger figure for this just a moment. How the normal contact force acts. The normal contact force on the block acts upward, no? And what is that direction along which it is acting? This dotted direction is the common normal, no? Correct. And how that normal contact force acts on the ground? It acts down, no? Action reaction pair. So how normal contact force acts? It acts along common normal. So if I tell you it is acting along common normal, what all choices you have? Either that force will act along this red arrow on the block, or it might act along this blue arrow along the block, along the common normal on the block. But which one I will select? The one by which I am trying to push this block away from the other object, which is this ground. So which way it should be applied? Upward, no, along blue direction. I hope all of you got this thing. Anyone having confusion regarding how normal contact force acts? It acts along common normal. How? Along common normal in a manner to try to separate the objects, the one which are in contact. No, what do I know? So acts along common normal in a manner to push the objects away from each other. I'll give more examples, just starting only. And I hope all of you understood why really this force has got. It's not like so many forces are there in the universe. Either force will be like force of gravity, or electromagnetic, or nuclear forces. So, but no, that's all. Three, four forces ruling the entire universe. So, if I have to guess, what will be the most possible correct guess? Will be electromagnetic. It's not gravity which is bringing normal contact, not nuclear force. What is remaining? Electromagnetic, no? And it is true only the electron, so A and B two objects, even though objects, but they have electron cloud around them. So electron cloud of one object repels the electron cloud of other object, which is something we call it as normal contact force. I hope it is clear.
So when normal contact force doesn't have any contact.
It requires contact.
So with electron clouds.
But that force is effective only when you are in contact. If you are like so far away, that force is completely nothing.
So contact is not actually like touching.
Touching only. Touching, but not like at atomic level they will touch. There will be some gap, but with naked eyes it will feel like touching only, no?
Fair.
Okay, clear, no?
Yeah.
I'll draw a few more diagrams. Suppose if I have a rod resting on, I'll draw the figure first. So we have a vertical wall and we have a horizontal ground. And this is a rod which is resting against a vertical wall and this surface. And it is a rod of mass and we have to draw the free body diagram of this rod. So at what all places it is in contact with the rod? At A, where at what all places this rod is in contact with the remaining universe? At A and at B. So we disconnect it at A and we disconnect it at B. But we keep the forces that were acting on the rod at the point A and B. Got the point? It's like um, we keep the money, but we to get rid of the person like that. Got the point? So what really the wall does to the rod at A? It applies some force. So we keep the force the wall applies, just we delete the wall. We keep the force the ground applies at B, but we delete the ground. And then we draw the diagram, which is called as free body diagram. So this is the rod I have. So first of all, if I ask you at the contact that it is having at B, one surface, the one which is it is in contact is the ground.
Sir, can you explain this diagram again?
I'll explain this diagram. See, this is the vertical wall and this is the horizontal ground. It's like a ladder resting against the vertical wall and horizontal ground. Right now, you might keep ladder like that, so maybe it is a ladder only. And we have to draw the forces that are acting on the rod. Mass is M. So it is in contact with the ground at B and it is in contact with the wall at A. Okay. So tell me for the contact point at B, if I drop a tangent, who is the tangent? The horizontal surface is the tangent, no? If I drop a tangent at the contact that it is having at B, this is the common tangent. So whenever one surface is flat, the flat surface will be, the flat surface itself is the common tangent, no? Is it not? What is tangent to a straight line? The straight line only. Then what is the common normal at point B will be, this red line will be the common normal, which is really the vertical. Now, at point A, which is the common tangent? This black line that I'm drawing is the common tangent. And whatever perpendicular to that tangent at the contact point at A will be the common normal. You see, this red line, which is really the horizontal, is the common normal. No? So for the contact at A and B, I know which way or which are the common normal. So at A, common normal is this horizontal dotted line. For B, the common normal is this vertical dotted line. So at B, only two choice I have. Either the force at B, which is the normal contact force, will act upward or downward. But how it should act at B? So as to push this rod away from the ground. Correct? No? So which way it will be acting at B? So it will be acting upward.
So will the rod give a force towards B?
That is there. That is for the ground.
Oh.
I'm not drawing the APT of the ground. I'm drawing the APT of the rod. So I must be indicating the forces acting on the rod only, no? Correct. So at point B, the normal contact force is going to be upward. And at point A, normal contact force will act along this dotted line, either leftward or rightward, but it must act in a manner to push this rod away from that vertical wall. So for that, it should be acting in this way. So normal contact force at A, I call it as NA. Normal contact force at B, I call it as NB. And what else will act? One more thing that will act, which is mg. So wherever you think there is the center of the rod, there you will be applying that force of mg. So just I'm drawing the ABD, nothing else I'm doing right now. So if you ask me how the forces that are going to be acting on the wall and the horizontal surface, that too I will indicate. So once I know, yeah, just a moment, just a moment, just a moment. Just tell me, you were telling me something.
Sir, how are you indicating the directions of the normal, sir? Both the normal.
Yeah, I'm indicating just a moment. I'll tell you. So at point B, I have to draw the normal contact force, correct? So at point B, which is the common normal, this red line, this vertical line is the common normal, correct? Correct. So on the rod at the point B, this normal contact force, whatever it is, must be acting along vertical direction, which can be two different directions. It can be vertically upward at B or vertically downward at B. But which way it must act on the rod at B, so that that force should be trying to separate the rod from the ground, upward or downward. On rod I'm talking about. Imagine no, this thing is resting on the ground like that. How the ground will be pushing onto that point wherever it is in contact with the ground, upward or downward. It will not be pulling it toward the ground, it must be pushing it away from the ground. So normal contact force at B acting along the common normal, but which way? Upward. And at contact point at A, which is the common tangent, this vertical line is the common tangent, which is normal to that is this red horizontal line. Correct, no? So normal contact force on the rod at point A must be acting along horizontal. Horizontal means it could be rightward or leftward at A or at point A. So which way I must apply that force, so that that force must be trying to push the point A of the rod away from the vertical surface. It must be rightward only. Clear, no? So how the reactions of those forces will act on the wall at A and B, it will be acting in opposite direction, but same magnitude. I hope it is clear to all of you. Clear? No? Easy only, no? Clear, no? Everyone? Clear, no?
Yes, sir.
Okay, just I will give you one. Please check out this question. This question actually. So picnic box. This question we will try now. Before we try this question, I have to tell you something, which maybe you might be knowing it from before, if not something big it is. There's something called Lami's theorem. Just a name, but you know already this thing. If I give you three vectors A plus B plus C equals 0, when such thing will be possible? When these three vectors are given by three sides of a triangle taken in same order, no? Correct? So resultant of these three vectors will be 0 only when they can become three sides of a triangle, correct? If at all they can't become three sides of a triangle, they can't give us resultant 0. So, and that is also called as sign rule in maths. So if I ask you that, okay, this is vector C, the angle opposite to that side, I call it as angle C. This is vector B, the angle opposite to side B, I call it as B. And the angle opposite to the side A, I call it as A. Then I can shift these vectors parallel to itself, and you will realize it's not going to be any different. So suppose if I shift B parallel to itself, A parallel to itself, not A parallel to itself, and C parallel, C, I'm keeping it there only. I hope you got it what I've done. I'm drawing B here, I'm shifting A parallel to itself, I'm drawing it here, right now. So this blue arrow of A also I can use. This blue arrow B also I can use, no? So this is our vector C, this is our vector B, and this is our, no, this moment. This is our vector A, and this is our vector B. So you will see what is this angle is, that you will find pi minus B. This angle you will find pi minus A, and if you find, you will get this angle as pi minus C. Sine rule states that these three vectors, the three sides of a triangle, only when A by angle opposite to that, which is sine pi minus A, must be equal to length of the vector B by sine of the angle opposite to B, which is pi minus B, and C angle opposite to the angle sine pi minus C. So sine pi minus theta is sine theta only, correct? No? So A by sine A must be equal to B by sine B. But even though you don't know this thing, you don't have to know. Just I'm telling some extra thing which rarely you will use. And even if you don't use it, it's totally fine. Even if you don't know this rule, it's not going to matter. I'll show you how. So if three vectors are giving us resultant 0, then it must follow this rule, which is called as sign rule. Okay. So for that, this vector A opposite angle, I will write vectors B opposite angle, what, no, B by angle opposite to the vector B. C by, you can check also how much this angle is. You will see that angle will come whatever I'm telling. So this is B. So this will be how much? You that thing that exercise on your own. I will show you how it can be of use and how it is of no use also using this question. So three vectors are given in same plane and their resultant will be zero if they follow this rule called as sign rule or sometimes also called as Lami's theorem. So this question we will try now.
So maybe can you go back to the previous one?
I'll go back. I'll go back. Just you know this thing. A by sine A, B by sine B, C by sine C. What really A, B, C are? Angle opposite to that. Because you write pi minus A or A, it will be same only. So if I use this triangle, it will be A is the angle opposite to A, side A. And the if I shift them parallel to itself, those angles will become
These are this thing magnitude.
magnitude. Because I thought we will write modulus and all. I wrote AB.
These are angles.
And these are angles. Okay. How to apply this thing for real? I'll take a question, but you don't have to apply this thing because we know how to find resultant using components of a vector. No. I can take a new page and keep on taking a screenshot also. Anyhow, I'll share it, but still for safety, take a screen because I am writing and suddenly this app crashes and like everything gets deleted one over. Okay, I can take a new page.
So,
So I hope you got the point. Just because I'm taking some extra class, I can discuss things with like more detail and with more luxury of time, and that is required for this chapter. The teachers are finishing syllabus. I don't know whether they're finishing syllabus or finishing physics only, but some I need more time. So that I'm drawing that figure, the one that is drawn already. So what are forces that are acting on that sphere are going to be normal contact force from the points where it is in contact with those two surfaces and gravity, no? So there's something which is property of a circle as well as a sphere that if you drop a normal, it will be passing through the center. So the cylinder is resting in a V-shaped groove, like between two inclined planes. And they're asking us how much is the normal contact force acting at those 2 points wherever it is in contact with these two surfaces. Just I'll draw a bigger figure so that it will be more clear. Teaching online I don't like, but still sometimes we don't have choice. If something you are not able to get it online, I will discuss it thoroughly in offline also. You don't worry about that. If syllabus don't get completed on time, I will get the syllabus reduced. But if he can complete, it is good for you only because then I don't have to hurry up things in the last months. No. So tell me one thing. This is flat surface. So what is the common tangent for these two surfaces? This surface only, no. So every time or most of the time, one surface will be flat only. So deciding which is common tangent is not difficult. This is also going to be. First, I will talk about that one. So if I drop it perpendicular to the contact it has got at the point, maybe I call it as A. So this is the common normal. Same way for the other surface, this is the common tangent. So I can drop a perpendicular at this point as well, which is suppose I call it as point B. So this is the common normal. Before I draw the ABD, you draw that ABD in your head. At the contact at A, how the normal contact force will act? It will be passing through the common normal. But how it will be acting? Pushing this sphere away from the surface. So same thing you try to figure out in your head how the contact force at B will act on the sphere along common normal, pushing it away from the surface. No? And if I drop a normal to a circle, it will be passing through the center. Wherever these two intersect, that must be the center of the circle. So tell me one thing, the angle between the horizontal and this first surface is theta. So what will be this angle, the one I'm drawing it with red? Find it out, but without making triangles. That can be the making triangle, but don't do that. You must have this habit. If I know angle between two lines, I can find the angle between the lines which are parallel to these two or perpendicular to these two. Angle between two lines, if it is theta, angle between their perpendiculars will be also theta. So the angle between this horizontal and this surface, we will draw something for them. Suppose this is green surface and this red horizontal. Angle is theta. So who is perpendicular to the horizontal? This red line, vertical. And who is perpendicular to the surface? This green line, no? I have got the point, no? This green line is the surface. Who is perpendicular to this green line? This green line. And this is the horizontal line who is perpendicular to that, this vertical red line. So the angle between these two will be same only, which will be theta, correct? There is some geometric thing. So since we are told this angle is also theta, so automatically same logic, this angle will be also theta, correct? I hope this figure is clear to everyone. Clear, no?
So this angle will be found here.
Yeah, same. No? Yeah, correct. No? Because this is the horizontal and this is the surface. Maybe I'll do the same exact thing here as well. This is the red one. This is the green one. So angle between the red one and green one is theta. So the angle between perpendicular to green one is this green one, no? And perpendicular to this red one is this red one. So angle between them must be same, which is theta. Okay. Now what we have is I will draw the free body diagram of that sphere. I will disconnect it from wherever it has got any connection with the universe. And I will be replacing those points of disconnection with whatever forces that were acting there. Just a second. See, normal contact force, the one which is acting at the point A, I will call it as Na. Normal contact force which is acting at the point B, I will call it as just a moment, this headache of teaching online. Just a moment. So normal contact force at A, I call it as Na. Normal contact force at B, I call it as Nb. And what is acts on him? Mg, no? Mg acts down like this. Just to show you how come you can apply that Lami's theorem, I will do it by that way, and then I will be solving it by the other way that you know already, by finding the component of vectors. So this angle we know it is theta, this angle we know it is theta. Suppose if I shift this arrows parallel to itself, it's not going to be any issue. Suppose NB, I draw it here. NA, I draw it here. So tell me, instead of using the black arrow of NB, I can use this blue arrow for NB, correct? So I'm shifting NB parallel to itself, just drawing it here. I'm shifting NA parallel to itself, drawing it here. So instead of using this black arrow for representing NA, I can use this red arrow to represent NA. It's not going to change anything, no? And just I will draw these two guys separately here so as to show things clearly. This is NB, this is NA, and this is NG. And how many forces acting on this object? Three forces, NA, NB, NA, and Mg. Mg is something which is equal to weight, which I call it as W. So you can tell how much this angle is. This angle is pi. How much this angle is? Can you tell me? This angle and this angle. All of you figure it out.
Sorry.
Yeah. Pi minus theta or not? I'm talking about this angle. This angle is 2 theta. This angle is 2 theta, no? This angle is 2 theta, correct?
So how did we get 2 theta?
This line same. This line same, no?
Oh.
This is theta, so that is 2 theta, correct?
Yeah.
And these two angles are same only.
Yeah.
And total angle is 2 pi.
Yeah.
So 2 pi minus 2 theta, each of total angle is half of that will be pi minus theta. So this is pi minus theta. This will be 2. You can check like this here also. First, I will draw that diagram. So you check. This angle I'm looking for. We'll use some different, maybe this pink color. Just a moment.
So is it 2 theta by 2?
Just a moment. This angle I'm asking you. So this angle is pi minus theta or not? Draw that thing in your notebook at home. Goes over. See this is a straight line, no? Correct. So this total angle is much
180.
180. This is theta. So what remaining this will be pi minus theta. That is one way to get the answer. Other way is that this one 2 theta. So this angle plus this angle together must be 2 pi minus 2 theta.
Yeah.
And half of that pi minus theta. However, you get those angles that totally depends upon like eye test, no? Like if you're still this is a straight line in online difficult, draw that thing at home. You will realize this angle, the one I've drawn with whatever pink color, no, and this is pi minus theta, because this green line OB and this red arrow are one straight line. So this total angle here, this one, wherever I'm using this arrow, hovering this arrow, that is pi. So this much, this pink part will be pi minus theta, because this much is theta. I hope all of you got that angle thing. Got it, no? So what really it is, so we will be writing A by sine A. So what I will do, NB, what is the angle opposite to NB? This angle, correct? This is NA, the angle opposite to him is this one. And this is W, the angle opposite to him is 2 theta. So I will write NB by angle opposite to it is pi minus theta. So sine pi minus theta, correct? And NA by, this is more headache way to solve. Just to tell you, I will tell by other easy way also. Sine pi minus theta. And Mg is W. So opposite to that is theta. So sine 2 theta. Okay, no? So now we have got these two equations if I write, or maybe if I want to find NB. So sine pi minus theta is sine theta. So NB by sine theta is equal to W by sine 2 theta. So NB will be equal to W sine theta by sine 2 theta. Sine 2 theta is 2 sine theta cos theta. So I can cancel one of the sine theta. So we get W by 2 cos theta, correct? Theta is 60 degrees. Cos 60 is 1 by 2. So answer will come W into 2. So W only. Same thing I can do. I can write this. Here I wrote first one equal to third one. No. Then I'll write second one equal to third one. We will have Na by sine pi minus theta is also sine theta equals W by sine 2 theta. Again, solving it, Na will come equal to W and became equal to W. But you will not, maybe there can be other way to solve this one by finding each of the vector in terms of the components. I will draw another figure in next page. Just have a look and take a screenshot, but you must be copying it after the class. I'll share the PDF also. The 1 hour we have saved now, and easy things only, just have to tell it once.
So this will come to the exam.
Lots of and easy things will come. Yeah. Just if you have understood things in the class, beginner box, if you will solve before the class, you will be able to solve the questions of Chinese level. Phase 3 runs like that, man, what to do. Or otherwise, I'll tell one line, I'll finish this level. That is not good, no?
Yeah.
So most of the people came 1, 2, 3, 4, 5, 6, 7, 8. So 2 people absent. No, 3 people absent. Okay, I can take a new page. I'll do it by more easier way. It's like how much headache finding the angles and all. Not headache. If I do it on board, it will be like so easy. A drawing figure is so much difficult task. So much less space I have to draw. But anyhow, all of you understood, no? Mani got it now? Aryan got it now? Revati got it now? Maybe they're joining with their parents' ID, maybe. So, I know there's no Revati in my class. Maybe it's someone reason. I can take a new page. So if you're listening, no, you must reply. If you don't have mic or something, reply with text at least so that I'll be listening. Otherwise, it feels
Yes, sir.
okay. It feels like radio jockey, and that's why. But I don't want to take extra class like this. But it is required, man. Otherwise, you will become weak in physics. So here I have Na acting. Here I have NB acting. This is how NG acts, which is W. This is our Na, and this is our NB. And this angle is theta. And this angle is also theta, which is given to us as 60 degrees. So you can tell how much this angle will be. So Na is like radially inward direction like this. And this dotted line is same vertical direction only. So there's a name for these angles, but you can tell this is same as that one.
Yeah.
Correct? No? So if I resolve Na, it will have two components.
These two lines are parallel.
Yeah, correct, correct. No, yeah, this one and this dotted and this vertical parallel, no?
Mm.
So this is same line only, correct?
Mhm.
Maybe I'll draw one something for it. Maybe I'll draw a green line for them.
So
So,
give us this line.
so this no,
No, no, that's not.
that I'm drawing it
Ah.
because suppose what really I have forces acting on him, which are in the plane of this screen,
Mhm.
or which are in the plane of this board. So how many components, any forces there has got two components only.
Mm.
So whatever forces are acting on this object are lying in this plane.
So
I'm telling you, I know what out you have. So whatever forces are having, every force can have only two components. So I find every force in terms of its components, which will be two mutually perpendicular components. No? So later on we'll see. Suppose if I ask you, take this as x, this as y, and whatever forces that are acting on this sphere are lying in this xy plane. So whatever forces components can have only two components. So I will find every force in terms of the components to find the resultant force in terms of the components, and that is zero. Because this sphere is under equilibrium, so net force on him is zero. So this force Na acting at an angle theta from the vertical. So how much is the component it will have in vertically upward direction? And Na cos theta, correct?
Yes, sir.
And along horizontal direction it will have Na sin theta. And all of you can tell which way these components will be. Same way, this NB will have one component this way and another component this way. So this will be NB cos theta and this will be NB sin theta because this angle is also theta. And this is how NB is acting and this is how Na is acting. And if I ask you, this is under equilibrium, means acceleration zero. Acceleration zero means first law net force must be zero, or even second law I can say. Net force zero, so I can say every component whatever forces can have must be zero. Net force along x must be zero, net force along y must be zero. So if I make net force zero along x, tell me what all forces are acted upon him. Na sine theta left side, Nb sine theta right side. Net force along x zero. For that, I need Na sine theta must be equal to Nb sine theta, correct? So what Na and B are equal? Na and B are equal. Let's suppose I call them as N. Next, I will make net force zero along the y direction. So what all forces I have got? Na cos theta upward, Nb cos theta upward, and W down. So to have net force zero, Na cos theta plus Nb cos theta must be equal to W, correct? And what Na and Nb are equal. So I will write them as 2n cos theta, which is equal to W. So what is our n is W by 2 cos theta. This is like lot for easier, no? And
what is W?
W is the weight mg.
Sir,
Like
how is Na cos theta is equal to N?
so you take out which one. See, it has got at point A, Na cos theta, how it is acting upward. Okay, and how Nb cos theta is acting upward. So two forces upward, Na cos theta and Nb cos theta. And what is down? Mg, which is I'm writing it as W. Okay, no. One word I'm using instead of Mg is W. So what acts down is W, what all acts upward is Na cos theta and Nb cos theta. So two forces acting upward, one force acting down. Total zero means whatever acting upward must be LCM is the one which is acting down. And while making net force zero along x, I got to know that NA and NB must be equal. Let's suppose they are N. So NA is N, NB is N. So what it became? N cos theta, N cos theta. So 2N cos theta, which is W. So how much N is W by 2 cos theta? This is better way, no? And this is like a lot more better than the earlier one. Just to tell you, there's something like sine rule, so that you will not say that did not taught sine rule. So I told that thing, not like you will need that sine rule ever. Okay. I hope all of you understood this.
It's an alternative method.
Which one? Which one, man? Which one?
This one.
And this one, how this became? So, so you think like this. I have a point object, not point object. Suppose if I had, what all forces it is having? Na cos theta upward and nb cos theta upward. And what else acts on him? Mg down. From left side, it experiences Na sine theta. From right side, it experiences NB sine theta. So I want net for 0 along horizontal. For that, Na sine theta must be equal to NB sine theta, no? So Na sine theta same. I can cancel them. So what is Na NB equal to? And net force along vertical will be 0. So Na cos theta, NB cos theta, upward, must balance the Mg, which I'm calling it as W. Now clear, no? Now clear, no? Okay, then. Okay, so time is also over. So those who came, thank you for coming for this extra class. It helps me a lot. And not like helps me, it helps you only. But otherwise, I'll be finishing this thing fast. That is not required. Every teacher does like that. I can't do like that. So I will say this thing. So only thing that we have done today is what normal contact force only. And right now, so do things properly so that everyone understands everything in proper manner. It takes time. Okay. So tomorrow also we have class. Okay. So let's see. So don't miss that tomorrow's class. Even though I'm going to share the recording, being live is like required. Okay. So today's date is 18th August, phase 3 weekend. Okay. Well, then, any doubt if you have, you can ask, or maybe I'll end the class. Okay. Okay, then bye everyone. See you tomorrow sometime at 5:40 to 7. Okay.
Sir, when will you keep classes for phase one, sir?
For phase 1, for backup class, no? Backup class. Tomorrow I will continue this laws of motion only. For phase 1, not required. Our syllabus over. No, and just the unit backup class.
Okay, so yes, sir, I'm asking for backup class, sir.
So tomorrow again same timing.
Okay.
Same timing. 5:40 to 7.
Okay.
Okay. Okay.
Thank you, sir.
Okay. Bye.
Should not listen that so normal forces it will be like through the central mass of
It will pass through center sometime. Depends upon what kind of object it is.
all the other case in this
It may not be. Suppose this is like here.
Can we leave, sir?
You can leave. Totally. Yeah, man. Leave. No problem. Okay. I have shared the PDF also. So this pen is resting here and here also. For normal contact force acts here. Along the common normal this way.
Thank you, sir.
So where it is a contact, it is happening here.
Only two
Yeah, contact. So maybe if it is like here like that, maybe if it is here resting here, then maybe. But depends, no? I can't say every time. Don't depend.
Thank you.
No problem. Bye. Okay, Manish, bye. I've said the PDF.
Thank you, sir.
Yeah.